You want these? Here's your vocab. Why what? How do you average two numbers? Well, if I want an average velocity, if I've got a steadily changing velocity, I can add my beginning and my end and divide by 2. This is V average. I told you something about the initial. I asked you something about the final. So this is a relevant formula. All righty. Questions thus far. Don't put this in the Google Sheet. Let's have it out loud. Any questions that you could think of thus far? Maybe not that you have, but you think your neighbor might have about understanding and applying this. Questions that you or your neighbor might have. Solid? Not liquid, not gas, but solid? Yes, in the back. Yep. Which? For I. Okay, so for D, if I know the initial and final velocities, if I know the initial and final anything, I can form its average. And a true statement about something that changes smoothly from one value to another is its average value produces the same displacement in the same time. I mean, that's sort of just a rearrangement of equation B. Yeah, good. Wait, you had a two-part question. Where's the second part? Hey, good. Okay, so now let's go on. How did we just do this? I gave you a chance to apply them to the first three. So I should give you a chance to apply C, D, and E. Okay, for what? For what are these? J and KL? For J, I'm just looking for a number, right? But for K and L, I want you to find two different equations that let you calculate the displacement. That means I'm not looking for the number, I'm looking for the equation that you apply to get the number, and I misspelled displacement. Okay, so for K and L, don't tell me the 100 meters it turns out to be. Tell me what equation you would get to solve for that. Ready, set, go. Oh, and timer. This is worth 5. Yeah, you see? I swear I'm going to post these for realsies this time, by the way. I always forget to post the PDFs of my notes. Swear they're going up this time. If you were taking pictures. Huh? I did not copy a word you said. One more time?
Basically lock yourself in the actual
I mean, it doesn't even take long. It's just that I'm such a freaking absent, freaking minded, freaking professor. Yeah. No, I will. I will. It's just I've intended that all semester to do that. And Who's just stuck? I don't see anything going in. Okay. Maybe I should give the equations up here first. You don't have these, you're dead in the water. If you know these equations, we're applying C, E, F. And everything gets easier. Yeah. Crap, that requires that I remember. J is absolutely correcto. K, what V? Which V?
Okay, specify.
Be specific. And L, no, you're missing a V initial. That one won't give you because I told you an initial V. Right. Didn't I give an initial V? Yeah, there's an initial velocity. So half AT squared alone is not enough.
Oh, wait, no, I am gonna speak. No, I get
Okay, that's time. Go back to the questions. Wait, say it again. I'm sorry, I am old and feeble and cannot hear. Please shout. Sorry. I'll bring my hearing trumpet next time. The last problem I said solve 2 different ways. You could solve it 3 different ways. Any equation that involves delta x here, D, E, and F, you can apply to solve that sucker. I will say that one equation, and this is true for any problem that I give you to solve for any of these variables, there will be an easy way and a harder way to do any given equation. The easy way you could do in a single step, the hard way you will have to do in 2 steps. But I mean, 2 steps, that's not the end of the world. You got good? And again, I'm gonna post this. I swear, for realsies this time. You won't have to look at the YouTube. Okay, I'm gonna move on. I'm gonna do these, apply these. For this sucker, if I have the acceleration, oh, well, the acceleration, velocity is acceleration in time. This makes me think of, well, the equation that links acceleration, velocity, and time is the defining equation for acceleration. A is defined as the change in velocity per time. Well, I've got A, 4 meters per second squared. I've got T, 5 seconds. So what does that give me? 20 equals what? Change in velocity. Please note, V over T is not A. V over T is, oh, I don't know of a physics concept that's V over T. It is how velocity changes divided by how time changes. So 20 is not the answer. If I start with an initial velocity of 10 meters per second, ooh, really hard algebra here. Correct answer was V final equals 30 meters per second. See how many people got that? A bunch of people got that. Good. Not everyone, but lots. And 20 was way more common in the 3 o'clock. You guys see through that. Okay, now there are, as I said, at least, probably even more ways to apply these equations to get the displacement. Here are 3 possibilities. First off, I could use the V initial plus V final. I've got these numbers, so I might as well plug them in. V initial 10, V final 30 times 4. 10 plus 30 is 4, over 2 is 20. I mean, 10 plus 30 is 40, divided by 2 is 20. T is not 4. 20 times 5 is 100. Okay. Now the other methods must also give you 100 or physics is broken. Displacement is also equal to V initial times time step plus half A times time step squared. Well, let's see, I could just plug in. I know V initial. I know final time. I know acceleration. I know final time. 10 times 5, 50. Half of 4 is 2. And 5 squared is 25. 2 times 25 is 50. Oh my God, it's like physics isn't broken or something. I can use V final squared equals V initial squared plus 2AX. To be precise, 2A delta X. V final, 30. 30 squared is 900. V initial 10. 10 squared is 100, last I checked. Okay, solve this equation for delta X. First, I get rid of the 100. 800 equals 2 times 4 goes by the name 8. I guess delta X equals, you'll never believe this, the same answer as before. Any of these 3 methods works. Please.
How did you get
This? Oh, so this is the idea that the change in a quantity is its final value minus initial value. I found the change. I was given the initial. So if you want the final velocity, you can't just say that the change. The change is not the final. Not if you're starting from 0, change is final, but not in general. Good. Okay, we're done with kinematics. Well, no, but this is your starting point with your studies. If you don't know one of these equations, you at the very least need to know that there's an equation that relates those quantities and where to look on your equation sheet to get the equation that relates those quantities. If you check something and maybe got it wrong the first pass around, look, I will let you guys study how you like, and I will not harangue you here about the most efficient way to do. OPQ. Callie, it's saved them. Just submit a response. Callie, no, it won't. It won't. Promise. I just see you twice. I didn't set a timer, did I? Oh, I'm so smart. I did send the announcement that I promised I would. The answers. Net ma. MG. K delta X. To be precise, I'm including the minus signs because I said vector here. If you just told me magnitude and you know the direction by common sense, I'd give that credit too. But to be strictly correct, I included a vector sign. Oh, I can actually indicate a vector there as well. Kinetic friction and static friction, you have to apply reasoning to figure out the direction of the force. So I can't actually just write this as a simple plus minus. Okay. Every single thing we do can be built out of these. In the dynamics chapters anyway. Is good? Do you know these? Or have you written them down? Eh. I mean, MU is its English transliteration, but I accept U, I accept M, I accept oh. Well, M is stupid because it really means mass. But I think MU or U probably makes the most sense. Okay, now let's apply these here. This isn't LMN, this is RST. Ross Stinky Tucker. And yes, you will have to think a little bit about what is going on for T. Sorry, not sorry. Ooh, lots of correct answers for this. Good. Good. And I'm going to round. If you don't round, whatever, by the way. There's still a lot of blank spaces. Should I give you guys another minute? Okay. First one's wrong. You do the first one. Yeah.
Thank you.
Second and third are right.
Right, that's all. 8.
Nope. Just 8. Springs don't require motion. A spring still springs without moving. They're two different. We use the same letter, but they mean different things.
Maybe.
We use the same letter for multiple things. We ran out of letters. Okay, numero uno. What's the physics that connects forces, masses, and accelerations? FMA! Exactly. Acceleration equals net force divided by mass. Net force in this 15 plus -5 is 10. Mass is 8. Acceleration is 1.25 meters per second squared. Weight, the weight formula. I'm going to write down the magnitude because I'm lazy and I can't be bothered to write down a negative sign. (9.810). I don't want to sit up here with a calculator. I want to be able to do it quickly for you. And last, what's the spring equation? Well, the force, the spring force, is equal to what I want. I'm stuck. I can't solve for mu without F. Well, question, thought? The negative sign in a vector tells us its direction. Weight is always down. So if I specify the weight vector, that little hook over the top of the symbol, that is asking me the magnitude, mg, and which way it goes, negative sign. If I know that weight is downward, I would accept mg as long as you promise that you know that weight points downward and that you will apply the downward direction for a force as appropriate. I'd accept that. So there's a negative because that indicates the direction of weight, but I'm not applying that here. I'm just asking about magnitudes. Okay, anyone know how I can get static friction, the spring friction, spring force here? What do I do? Am I stuck? What could I do? Thinking is allowed. Am I stuck? Jane, what do you think? Brilliant, egads, eureka. Assuming that the dog is standing on the scale, is just standing there, is not wibbling, wobbling up and down, assuming that the owner isn't patting the dog. My mental image says there's a spring scale pushing up. There's a weight force pulling down. And in absence of other information, those are going to be equal. Weight equals spring force. So I'm just going to plug in mg. Because that's, if you visualize the scenario, that's a reasonable picture to have. Final answer K is about 2000. Again. Newton's laws describe like literally everything, every possible scenario in the world around us. Everything obeys Newton's laws. Almost no exception has ever been found, even in modern physics, 400 odd years later, 350 odd years later. So there is no simple, if you see this keyword, use this equation. If you see that keyword, use this equation. Answer. You cannot always memorize, for instance, that spring force equals weight force. That's not a true statement. Since physics describes everything, you actually have to use your brain to imagine things and what makes sense to apply in any given situation. I realize that this is immensely frustrating for you, but sorry, there's no other way to do it. You have to picture what's going on. If you got 1960, that's if you use 9.8, whatever, I don't care. Okay, likewise, for what are these? UV. For U and V, you got to actually picture what's going on. You have to think and visualize and apply reasoning to this. Sorry, not sorry. Good for you. Yeah, 0 to 30 in 5 seconds. Sure. No, that's bad. That's no, I don't want to do that. I'll rewrite it.
Just glitched out and I did everything up
Yeah.
to M.
So if you hit fill out a new response, you'll appear twice in my forms, but your answers won't be, you'll still get credit.
Okay, because what's it called? Yeah, I had these filled out and I submitted, and then randomly it just said could not find page. I went back and all these are gone now.
It's fine. It's fine. You'll still get credit.
I'll just start from Curvo.
Yeah. If you're struggling with you, I may encourage you to do the same damn procedure we did for a month, 5 weeks. Draw a picture, draw a bubble, identify the forces, draw a diagram and write Newton's laws. Bam, 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 step by step. You do have to visualize what's going on. There is a procedure for doing that. Question or stretching? Yes. But double check what the Canvas page says, because my memory is worth double checking. Yeah. All to build you up to this. Okay, we've got 13 minutes left in class. Wait, 8 minutes left in class. So I want to actually go into you. Again, les procédures, 4 problems. If you don't know what to do, sketch it. Draw a box around. If it exerts a force on, then it's either weight force or a touchy force. There is a ground beneath their feet. So methinks there may very well be a normal force upward. There is a planet beneath their feet. Methinks there's a weight force downward. Hey, if they're moving forward, what force is acting on them in the forward direction? Trick question. You don't need a force to move. You need a force to change your motion. At some earlier time, presumably there was a forward force to get them moving, but motion velocity is not a force. Velocity is the result of forces accelerating something. So there is no forward force. The ground can also exert a friction force, and that's the backwards force that's slowing them down. There's your free body diagram. Ain't no other forces, ain't no other objects touching them to exert those forces. Okay, so if that's our free body diagram, if that's our force diagram, then what can I conclude? I can write down F equals ma in each direction. Normal minus weight equals what? Well, in this direction, are they falling through the ground? Are they accelerating up into outer space? No, acceleration vertical is 0. In the what? In the left-right direction, the friction force is backwards, and that's equal to its mass times its acceleration. Well, I've got a model for friction force. I know something about friction force. Friction force is mu n. Kinetic friction is always mu n. Oh, look, it's something I want. Something I want, and everything else is terms that I've got. Normal minus weight equals 0. I deduce normal equals weight. Oh my God, 300 newtons. Mu k is what I want. Times normal is 300 equals mass is 30. The acceleration is negative 0.5. Math, mu k equals 0.05. Oh my God, you got it right? Good job. Good. By the way, there's more than one way to do it. If you did it a different way, you get full credit. Also, I rounded 9.8 to 10 because I wanted to. Turn to your neighbor and discuss. All of the steps for the process are important in the more sophisticated problems. So please discuss the how I got it as well. Ready, set, go. Take a minute. Okay, I will take questions. I want questions. You should ask questions about this, but let's do the last problem real fast. Free body diagram, same thing except friction is the force that pushes you forward. Do you remember that? Static friction is how we walk, is how we drive. Unless the car is burning rubber. So I think static friction force is the net force. There's only one force pushing horizontally. The traction on the ground, that's the static friction. And if I say minimum mu s, I'm talking about at an extremum. Any less mu s and I'd be slipping, I'm talking about at the slipping point. So I don't have to apply less than or equal to. I could just say static friction is equal to its limit. I am getting as much out of friction as static friction as it'll let me. So I could plug in mu s in. And just like in the previous problem, nothing else going on vertically, n is mg. Oh, look, m cancels. So the only thing in this problem really is to find acceleration. Mu s times g is change in velocity, change in time. Solve 0.6. Okay, now I strongly encourage you. Google question W. Ask me a question about the method, or ask out loud, that's allowed too. And listen to the answers for your classmates. Yeah, talk to me. Sorry? Yeah. Sure, we can do that. Okay. Negative 300 mu on the left, yeah, equals negative 15. Yeah. Mu times n. Negative what? I think you did 300 over 15. 15 is smaller than 300. The answer can't be bigger than 1. Also, just I happen to know this, and now you do as well. It is very rare for coefficients of friction to be anything but between 0 and 1. Most material pairs have coefficients of friction between 0 and 1. It's not a universal law. You can have bigger than 1. That's rare. Question me. Any verbal questions, out loud questions? Please. Yeah. In this case, the only force accelerating the skater is absolutely, well, in both of these cases, I'm allowed to, it only makes sense, the only thing acting horizontally is the friction force. In this case. But maybe I give you a problem where there's a friction force forward and a tension force backwards. I don't know. You have to apply on the individual merits of every case. Yes. Yes, you're absolutely right, what you just said. What is the only horizontal force? Static friction, kinetic friction. So I plug in his formula. Leftward magnitude equals ma. Good. Other questions, please. Mhm. Mhm. The maximum what? That's the maximum force of friction. So I am asking, when you are getting as much out of static friction as possible, any less static friction and you'd be skidding, sliding, burning rubber? If you are getting as much friction as possible, what is the least value of mu that gets that? You're at the limit, you're at the boundary between slipping and not slipping. So you're allowed to plug in, it's not just less than, it's equal to. And if you visualize it, if mu got any smaller, the maximum force would be too small to get this acceleration. Good question. Any other questions? We got 2 minutes, don't leave yet. No, we're 2 minutes over. You get to leave. Adios. Love you. Bye.